Learners, in this program, we would discuss about the geochemical data of basaltic rocks with an example from Deccan traps. The focus would be on the interpretation of major oxides, trace elements, and radiogenic isotopes.
So far I have discussed about the interesting part of the Deccan volcanism, about its origin, various topographic and field features, and how these rocks can be seen through the eyes of the microscope. That I have already discussed before you, and you may appreciate how interesting, how colorful these rocks are. At the same time, I would show you, I would like to give you more information with the eyes of a chemist. What is the chemistry of these rocks? Chemistry may be, I hope, may be more interesting than the petrography, and here is the chemistry. See here, this province in India is one of the most well studied, and see how research activities were carried out in this area. The research activity started with my teacher Professor West in 1958, and since then continuously hundreds of research papers have been published, and I have shown you here the major research activities. Those activities they have been carried out in this province here. First I will take up the major oxides. What are the major oxides or major elements? Major elements are those elements which constitute 99.9% of the bulk of the composition. So, 99.9% of the bulk of the composition of this rock is composed of 8 major oxides, and the change in this major oxide chemistry is very important in order to study these rocks. Each lava flow has its own chemistry. You can appreciate how diversified chemistry of these lava flows is. The 8 major oxide variation is very significant, and there are certain oxide variation ranges through which you can distinguish one lava flow from another lava flow. Here I would like to show you the highlighted portion. These are the ranges through which you can classify, you can distinguish, you can identify, or you can group certain number of lava flow into a chemical type. Viewers, see here, lava flow is a single unit, it is a unit. Lava flow, group of lava flow having similar character is known as chemical type. Some of the chemical types having similar characters, they can be clubbed under the formations. Formations 1, 2 or more than 2, 3 formations, they are grouped together as subgroups, and finally they have been grouped as a group. So, Deccan basalt is a group of rock, and Deccan basalt is a group of rock, and it has 3 subgroups and 13 formations. See here the variability of chemistry of these rocks, 13 formations and several chemical types. How powerful this major oxide chemistry is, you may appreciate when we plot the major oxide composition on a bivariate plot. See, the plot between magnesium and potassium oxide, it has a separate field. The yellow color field represents high alumina quartz normative tholite. It has a nomenclature, it has a very lengthy name, but it has a separate major oxide characteristics. Similarly, low alumina quartz normative tholite. Similarly, you have high alumina hypersthene. Hypersthene is also a mineral. Tholite is a variety of basalt. Then high olivine normative tholites, high diopside olivine normative tholite. So, these are the various technical terms. Depending upon the major oxide compositions, they have been applied in order to describe these rocks, these volcanic rocks into different categories. After the major oxide composition, let us talk about the trace element. Trace elements, those elements which are present in traces. What do you mean by traces? Their concentration may be less than 0.1% of the total bulk composition. Although they are very low in concentration, but they are very significant. Why they are significant? Because their signature, their abundance in a particular lava flow signifies or characterize a particular lava flow, group of lava flow, chemical types, formations and groups, subgroups and groups. These trace elements are basically ytterbium, barium, thorium, strontium, niobium and yttrium. Barium is important. Why barium is important? Barium is not present in much high concentration in basic rocks. But if barium is there, where from this barium has come? It has come from the crust, the acidic crust, because when this magma was ascending, the basic magma was ascending, because of heat the surrounding rocks they underwent melting and a hybrid magma is produced. That hybrid magma, actually the whatever rocks, country rocks or the crustal rocks, they underwent melting, they incorporated into the basic magma and as a result hybrid magma was formed. So, barium is incorporated from the crust, granitic crust. So, barium, strontium, all these elements they have been derived from the granitic crust. Apart from the absolute concentration, the elemental ratios are equally important, such as barium by yttrium ratio, zirconium by niobium ratio. Zirconium, niobium, they are important. In geological terms, they are better known as hygromagnetophiles. Hygromagnetophiles means they are the large ion lithophiles. Large ion lithophiles means they have large ionic radii, at the same time they have low charge. So, when they have a large ionic radii, what will happen? They find difficulty, they means zirconium and niobium element, they find difficulty to enter into the lattice structure of the silicates. That is why, because of this phenomena, these elements are very important. Their concentration in a lava flow or in the chemistry, that is very important, and based on these concentrations you can classify, you can distinguish group of lava flows into different categories. Though you can classify them into chemical types, formations, subgroups and groups. These are basically niobium, strontium, zirconium, ytterbium, zirconium by niobium ratio, and their ranges are very well defined here. In a particular chemical type the range may be 17 to 26, but in another chemical type the range may be something different. So, this is how we use this chemistry in order to study these rocks, and we plot these concentration on bivariate diagram, they form a separate field. Similarly, we plot these concentration in stratigraphic order. You mean to say what is stratigraphic order? When we plot these concentration according to the stratigraphic heights. With respect to stratigraphic heights, they form a separate field. That means, set of lava flows having a distinct chemical characters. See how distinct fields are there. Each formation is identified. These formations, they have been assigned local names like Mahabaleshwar. Mahabaleshwar is one of the most interesting tourist point for general public, where a particular group of lava flows have been developed, and these lava flows having a certain set of chemical characters. Therefore, these lava flows they find a separate field here in the bivariate diagram. Similarly, Pollardpur is also a local name near Bombay. Pollardpur, where set of lava flows are very well developed. They display a set of chemical characters shown with the help of yellow colored field here. So, you may appreciate each formational field having a distinct character, distinct chemical character, or with the help of distinct chemical characters each formation can be easily identified. These formations, they are 13 in number. Chemically, how these lava flows are diversified. But what are the processes which were responsible for such kind of diversification? Fractional crystallization, crystal contamination, mantle mixing, these are the processes by which these lava flow show different types of trace elemental concentrations. When we study these lava flows, we have to use certain techniques, statistical technique popularly known as discriminant function analysis, where the trace element and major oxide trace elemental data or elemental ratio, they are taken into consideration. Why we use statistical technique? Because we have enormous parameters, maybe at least 50-60 parameters. At the same time, we have large number of samples. I have studied at least 628 samples multiplied by 40 parameters at least. So, in order to handle such a big database, we use statistical packages, and discriminant function analysis is done using statistical package SPSS. See here 624 samples of the southwestern formation. These are the variables which I have shown here, and we have calculated Mahalanobis distance and the group centroid and many other things. I would like to show you here, citing one example, that the Boucher formation which I have stated earlier, or the Poladpur formation or the Mahabaleshwar formation, F1 and F2 factors, the value of these group centroids B or P or M is distinct, and closest to this group centroid shows affinity towards that particular formation. So, in the field you do not know anything, anything means you do not know the chemistry, but when you analyze these rocks, where you will place these rocks, how you will place? First you analyze them and go for a statistical analysis, see where these rocks they do lie in these packages or in these fields. I have discussed major elements, I have discussed trace element and elemental ratios, but radiogenic isotopes are equally important, and radiogenic isotopes, each formation having its own arrays. When we plot radiogenic isotopic ratios XY plot, for example, lead-lead isotope on the abscissa and strontium 87 by strontium 86 isotope, epsilon Nd isotope or epsilon Nd total isotope, when we plot it, all the formations, all 13 formations, they form a separate field or arrays in a bivariate plot. So, any unknown sample, when you analyze for isotope analysis, if you have this isotope data in your hand, if you plot those values over this bivariate diagram, you can easily ascertain which formation it belongs. Now, what are these formations? If you see the entire Deccan volcanic province here, right from Saurashtra plateau, Malwa plateau, Deccan plateau, Mandla lobe or the Mandla plateau, there are Deccan basalt is a one group of rock subdivided into 3 subgroups: Kalsubai subgroup, Lonavala subgroup, Wahi subgroup. The lowermost subgroup having 4 formations called as Igatpuri Jawhar formation, Neral formation, Thakurwadi formation, Bhim Shankara formation. It is overlain by Lonavala formation, Khandala formation, it is a very good picnic spot, Boucher formation, and it is further overlain by another subgroup of rocks called Wahi subgroup. Wahi subgroup comprised of Poladpur formation, Ambeneli Formation, Mahabaleshwar Formation, Panhala Formation and Desur Formation. These are the formations and their respective thicknesses are also written over against each formation. You may appreciate Thakurvardi Formation, how thick it is, 650 meter thick, almost more than half a kilometer thick formation. See how magnificent these rocks are there in our country. So, this is about a very general idea about the chemistry of these rocks. Chemistry I have explained in terms of major oxide, trace element, trace elemental ratios and isotopic ratios.
Now let us summarize what we have learned. We have briefly learnt about the interpretation of major oxides and trace elements of the basaltic rocks with a case study from Deccan volcanism. Thank you very much.